Shapes. They are everywhere, and today we profile the triangle on History of Triangles. One of the most famous math theories of all time is the Pythagorean theorem, which was founded in Greece somewhere from the years of 500 to 569 BC by a man named Pythagoras. Now, Mr. Pythagoras was credited for finding the Pythagorean theorem, yet other ancient civilizations such as the Babylonians, the Chinese, the Indians, and the ancient Mayans were thought to have known of this theory even before Pythagoras. Now, the Pythagorean theorem states that for any right triangles, if the two legs are A and B, and the hypotenuse is C, then the formula A squared plus B squared equals C squared will always be true. And again, I cannot stress this enough, this is only for right angle triangles. It will not work for obtuse or acute triangles. Okay, so now let's see if this formula actually works. So assuming two legs are 3, 4, and 5. So that's 3 squared plus 4 squared must be equal to 5 squared. So 3 would be A, 4 would be B, and 5 would be C. So 9 plus 16 would be equal to 25. So thus 25 must be equal to 25, which means that this triangle is a right triangle. Now, Mr. Pythagorean had lots of followers who would often refer to him as the son of Apollo, who is a famous Greek god. They worshipped him in a cult-like society and were sworn to a life of secrecy. Now, though Pythagorean taught his followers everything he knew, they were not allowed to write any of it down. One half base times height is equal to area. It's the common area formula for a triangle, and it's thought to have been founded by the ancient Egyptians when they created the pyramids of Giza. Now, one half base times height for the area formula is perfect if you know the base and the height, but a lot of times they won't give you the height. You will not be able to find the height. So for this we needed a hero, and the hero was found in Heron. So Heron found something called Herons Formula, which uses the three sides of a triangle to find the area, and it says that area is equal to the square root of S times S minus A times S minus B times S minus C. So A, B, and C are the three side lengths, and S is equal to A plus B plus C, all divided by 2. Okay, so now let's try to apply this to an example. So we'll use the same right angle triangle that we used for the Pythagorean theorem with sides 3, 4, and 5. And we'll use the normal 1/2 base times height way of finding the area. So if you use the 1/2 base times height way, it's 1/2 3 into 4 is equal to the area. And if you do 3 times 4, it's 1/2 of 12 is equal to the area. So thus 6 would be equal to the area. So remember that using the normal way, we got 6 as the area. Now let's try Heron's formula. So let's draw the same triangle again with legs 3, 4, and the hypotenuse of 5. Now using Heron's formula, first we would have to find S, which is 3 plus 4 plus 5, and then divide that all by 2. So S will be equal to 12 over 2, so S will be equal to 6. Now I know this is the same as the area, yet S is not the area. In this certain scenario, S is the area, yet S will not always be the area. So let's draw this triangle again. 3, 4, 5. 3 is A, 4 is B, and 5 is C. Since we will need to know that, since we will need to assign each one a little letter to use Heron's formula. So the area is equal to the square root of S, which was 6, and then S minus A, which is 3, and then S minus 4, which is B. Now remember S is 6 times 6 minus 5, and 5 is also equal to C. So now if we just do the stuff in the parentheses, we'll have area is equal to the square root of 6 times 3 times 2 times 1. So that's area. Let's multiply all the stuff in the parentheses. So area would be equal to then 6 into 6. So area will be equal to, if you do 6 times 6, because those are the two stuff in the bracket, you will get the square root of 36. And if you easily find the square root of 36, you'll find that the area is equal to 6, which is the same thing that we found for the first time that we tried it. So in 1414, a man named Al-Kashi came up with something called the law of cosine, which was true for all triangles. And what the law of cosine said was that for any triangle, c squared is equal to a squared plus b squared minus 2ab cosine c. Now, this is for any triangle in which the three sides are a, b, and c, and the angles are also a, b, and c. Now, what exactly was cosine c? So now we're going to try to find cosine, which is only true for right triangles. So we're going to assume the three sides are a, b, and c. So we're going to try to find the cosine of c. Now the cosine of c is defined as the adjacent side over the hypotenuse. Now this isn't just for cosine of c, this is for any cosine. This is the cosine ratio, adjacent over hypotenuse. So if c is 4, b is 3, and a is equal to 5, we're going to say that the cosine of c would be equal to 3, which is the adjacent side to c, over 5, which is the hypotenuse to this triangle. So thus the cosine of c will be equal to 0.6. Okay, so now I'll show an example of the law of cosine, and we're going to use an equilateral triangle just so we can find the angles. So the sides are a, b, and c. And again, just to refresh on the law of cosine, it is c squared is equal to a squared plus b squared minus 2ab cosine c. So we're going to have them all equal to 3 because it is an equilateral triangle and all sides will have to be equal. So that's 3 squared is equal to 3 squared plus 3 squared minus 2 times 3 times 3 into cosine c, which in this case is 0.5. So 9 is equal to 9 plus 9 minus 2 times 9 times 0.5. So 9 is equal to 9 plus minus 18 times 0.5. So 9 is equal to 18 minus 9. So this 9 is equal to 9. In 1200, a Persian mathematician who was named Al-Jayani came up with something that he called the law of sine. Now, what was the law of sine? The law of sine said that for any triangle, the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. Now, what is sine of A, sine of B, and sine of C? So what sine says is that for any right-angled triangle that in which the three sides are A, B, and C, the sine of C would be equal to C over A, which is equal to the opposite side of the angle over the hypotenuse. Again, the opposite side of the angle over the hypotenuse. So now let's try to bring in values to show an example. So let's say C is 4, A is 5, and B is 3. So the sine of C will be equal to 4 over A, which is 5. So the sine of C will be equal to 4 over 5, or 0.8. So now let's go back to the normal Al-Jayani's law of sine. So let's give all the sides values of 5, 12, and 8. And we'll say that the height is 10 because we need that as one leg. So we have angle A and B and sides A and B. Again, angle is opposite to side. So the sine of A is equal to the sine of B. So thus 10 over 5 over 12 must be equal to 10 over 12 over 5. So 10 over 5, which is 0.5, over 12, which will be equal to 10 over 60, which is equal